Alrighty, kiddos. Another example. This is in your packet, problem number 118, and it's what I'm going to call a distance rate problem. The last two that we did were work. Now these are distance. Let me move my mouse. See if I can. There we go. Better? I think I've got my light on. Nope, let me turn my light on. That might help. Little bit brighter. Okay. So the speed of the current in Puget Sound is 5 miles an hour. A barge travels 26 miles with the current and returns the same distance. So it goes 26 miles down and 26 miles back. The round trip took 10 2/3 hours. What is the speed of the barge in still water? Now y'all might remember we did these last year in Algebra 2, but we did them as a system of equations. We set up two equations with two unknowns, and we solved that way. Now I want to show you how to do it with a rational equation. I don't know which one is easier really, but this is the rational equations chapter, so this is the one that we're going to do. So let's start with our first formula. Distance equals rate times time. And Josh, we're talking about a velocity today. Distance equals rate times time. And I'm going to make us a chart. So this boat, this barge is in the Puget Sound, and it goes one way with the current, so it goes faster. And then on the return trip, it's against the current, so it goes slower. Distance, rate, and time. Now if you all recall from Algebra 2 when we did literal equations, I know Chayton, you're rolling your eyes, distance equals rate times time. If I want to solve for time, I divide by rate, I divide by rate. Time equals distance divided by rate. That's going to be important. Okay, so looking at problem 118, it says it travels 26 miles with the current and it returns the same distance. So my distance is 26. It says that the speed of the current is 5 miles an hour, and what we want to know is the speed of the barge. Okay, so I'm going to call R the speed of the barge in still water. Now going with the current, the barge goes an additional 5 miles an hour because it says the speed of the current, is 5 miles an hour. So with the current, we've got the barge and it goes 5 miles an hour faster. Now against the current, it goes 5 miles an hour slower. Okay, downstream, upstream, it's got to go slower upstream because it's working against the current. Now look over here at my formula for time. It's distance divided by rate. So the time down is the distance down divided by the rate. The time up is the distance up divided by the rate. Now look back at the problem. The round trip took 10 2/3 hours. And I'm going to go ahead and change that into 32 thirds. 3 times 10 is 30 plus 2, 32 thirds. Okay? The time down plus the time up, and I'm sorry that my 5s look like S's, equals 32 thirds. There is my rational equation. Okay, let's go at it again. Distance equals rate times time. So if I want the time, because I haven't used that data yet, time is distance divided by rate, distance divided by rate, distance divided by rate, time down plus time up equals total time. Okay. Find my least common denominator, put brackets around the whole thing, find my least common denominator and put it out in front. So my least common denominator has to have a 3. My least common denominator has to have an r plus 5. My least common denominator has to have an r minus 5. Okay? Now we are going to multiply through and cancel as applicable. So that r plus 5 cancels with that r plus 5. So I have 3 times r minus 5 times the 26 that was already there. That cancels that. So I have 3 times r minus 5 times 26. Plus that r minus 5 cancels that r minus 5. So I have 26 times the 3 times the r plus 5. And I'm not being consistent in my order. I apologize. That cancels that. And so these two are left to multiply by the 26. Now I come to the 3. That 3 cancels that 3. So I have the 32 that I started with times r plus 5, r minus 5. And now I no longer have any denominators. Now it is a regular equation, and I'm going to do some simplifying. Now, looking over here, this is a pattern of factoring you should know. It is a difference of perfect squares, what we call DOPS. I am going to cut to the chase and say r plus 5 times r minus 5 is r squared minus 25. If you don't see that, FOIL it out. The 5r and the negative 5r will cancel. Okay? Over here, multiply the 3 times the 26 and then distribute. So 3 times 26 is 78. So 78 times r minus 5 is 78r minus 78 times 5. I'm grabbing my handy pink calculator. 78 times 5 is 390. So that's a minus. 78r minus 390. Now this one's going to be 78r plus 390 equals, distribute here, 32r squared minus 32 times 25 is 800. And the reason I can do that so fast is there's 4 25s in 100. So 32 is 8 copies of 4 25s, so that's 800. Okay? Like terms, cancel, cancel. Combine these, that would be 16, carry my 1, 156r equals 32r squared minus 800. What kind of equation is r squared? There's your answer. When you do a quadratic equation, you have to get everything equal to 0. So I'm going to move that over. 0 equals 32r squared minus 156r minus 800. Okay. Now, we are going to factor this. And the first way it factors is by greatest common factor. The greatest common factor of 32, 156, and 800 is 4. You might have to play with it a minute to see that. When I factor out of 4, I am left with 8r squared minus 39r minus 200. Now, it is a gentry or a gentry, which is a box or a slide or an asterisk or a grouping, however you want to do it. I'm going to do it by box and by slide. Okay. So if you need to copy down, pause the video here because I'm getting ready to go onto a separate sheet of paper. And I am going to scan all these pages in and upload this document too so that you can print it at your convenience. But I think it's you learn better if you do it on your own. All right, so let me take this paper away. So what am I doing? I am factoring. Let me copy out my equation. I'm factoring this guy. So 8 times 200 is 1600, and I'll worry about my signs in a minute. I put it in my calculator under the y equals 1600 divided by x, and I want to find a pair that subtract, and the reason I'm saying subtract is because of this minus here. The subtract to give me 39. So I've already done that because I've already worked this problem out on a separate sheet of paper that I'm referring to, so I don't act like an idiot. It's 25 and 64. 64 take away 25 is 39. To get my signs right, a negative 39, it's going to have to be a negative 64 and a positive 25. So in other words, you're thinking 25 take away 64 is negative 39. All right, so I'm going to box it first, then I'm going to slide it for Ryan, and I think Caleb likes the slide too. These two boxes are filled in with these, and it doesn't matter which one I put where. You'll get the same answer either way as long as you put an R with it. So that one is here. These two make that one. This one is here. Now I'm going to do greatest common factor 4 times. The greatest common factor of this row is R. The greatest common factor of this row, what goes into 64 and 200, is 8. And remember, the power player is negative, so it's a negative 8. The GCF of this column is 8 and an R. Power player is positive. The GCF of this column is 25. Power player is positive. So now I have this. That's the 4 that I pulled out in front, which does not affect my answer at all because it doesn't have a variable with it. Okay, that's box. Now, I'm going to slide for those of you that like slide. And remember, slide is not my personal preference, but if you like it, then I want to make sure that you can use it properly. So slide starts out the same way, 8 times 200, 1600. I find those same two numbers. I fill them in like I was doing what I call a trix, a trinomial that starts with x squared. Now I have to slide again. So I slide an 8 here, and I slide an 8 there. Okay. This reduces. So that's this piece. This doesn't reduce, so I slide the 3rd time, and I get that piece. Okay, so it's factored. Now, I've got 2 baby equations. I said each one equal to 0. This one you can do in your head, R equals 8. Now remember, R is the rate of the boat in still water. This one says 8R plus 25 equals 0. Move the 25 over. 8R equals negative 25. So R must be negative 25 eighths. Can a rate of a boat be negative 25 eighths? No. So this is a nonsense answer. Remember, I know you can't see them, but up on my wall, my 10 Commandments of Math, commandment number 3 says, "Thou must use thy common sense, else thou wilt have flagpoles 9,000 feet high, yea, even fathers younger than sons." This is like a flagpole 9,000 feet high. You can't have a negative rate. So that means the rate of my boat in still water must be 8 miles an hour. Okay. Now, I want to check that for common sense. Okay. With the current, the boat was 8, the current was 5. That means it's going 13 miles an hour. The trip was 26 miles. 26 miles at 13 miles per hour takes 2 hours. So it takes it 2 hours to go down. Then going back, the boat was going 8, the current was taken away 5, that means it can only go 3 miles an hour. 26 miles at 3 miles per hour takes 26 divided by 3 hours, because distance divided by rate equals time. 3 goes into 26, 8, with a remainder of 2/3. 2 hours plus 8 2/3 hours is the 10 2/3 hours we started with. So my final answer, answer has an N in it, is the rate of the barge in still water is 8 miles per hour. I'm going to stop this video so you can digest this problem.